Hi, Spring fans. In today's installment, we're going to talk about distributed transactions, or rather distributed locks with Spring integration. Now, this feature, along with leadership election, was actually something that came from another project in Spring Cloud and has since been sort of put together inside of Spring integration. In today's installment, we're going to very briefly look at distributed locks. And we're going to do so, of course, using my second favorite place on the internet, start.spring.io. No, wrong one. There we are. And we're going to build an application here, 2.20 M3. We're going to call this locks. And we will build an application here using JDBC and PostgreSQL and Spring integration. And that's it. The other dependencies we'll just have to add manually there. Okay. I guess we can do distributed locks with Spring integration. I suppose it's better safe than sorry. And we'll open that up. And now, in order to make this work, we need to add a few dependencies here. We're going to bring in the Spring integration JDBC support. So that's a custom dependency under the Spring integration project. But thankfully, it's managed for us by the Spring integration bill of materials. So we can just import it without qualification. All right. Okay, good stuff. Now, let's go to our application, and I'll rename this locks or something. All right, good stuff. Okay, there's our application. Now, what are we going to do? Well, we're going to talk to a database. So let's use we've got Postgres here. And what we're trying to do is to create a thing that will allow us to restrict access to some sort of state across multiple nodes in a cluster. So you might have 10 different microservices, and you want to make sure that at any given time, only one of them is operating on some sort of interesting state. And that could be a resource in a database. It could be a file in a file system. It could be whatever. It could even be that you want to serialize processing of requests for a particular user. So you want to make sure that while one node is processing a message intended to update the state of a particular user, nobody else in the system processes that same update, basically. That nobody else processes any update related to that entity until one node has had a chance to do that. So whatever the use case is, distributed locks are invaluable in ensuring consistency for certain kinds of use cases. And Spring integration provides a nice set of primitives that we can use to support that. So we're going to talk to a Postgres database here that is available here, and localhost 5432 and orders. Okay. Username equals orders and password equals orders. All right, that's my thing. I'm going to do server.port will be equal to 0, so because we're going to start up multiple instances after all, and I want each instance to get its own unique port. And then in the application, we're going to write a little bit of repository code to save things to the database. And I'm not going to do nothing too fancy here. Let's just do a custom repository, a very simple repository using JDBC. Keep it simple. Okay. I know I'm going to need a row mapper. We're going to need an entity of type reservation. So, okay. So we're just using regular JDBC template, spin and spring forever. So not a lot of code that we have to write. We can just use Lombok to bring in the to help us out with the boilerplate, the constructors, the toString, the hash code, etc., that kind of stuff. So we'll do that here at data, at allRx constructor, noRx constructor, and there's this. Okay, and call this a repository. Good stuff. Okay, so there's this. Now we want a couple methods here. One optional of reservation. Okay, find by ID, integer ID. I'm going to come back to this in a second. And then we'll have a reservation, save. Okay, we'll come back to that in a second. And we'll have a collection to find all. Okay, reservation, find all. Alright, come back to that in a second. Now, let's do the easy one first. I suppose that's this one. So we'll say template.query, select all from reservation. Alright, I'm going to use the row mapper. And there we go. That's the entire thing. We want to do the same thing for find by ID, but if it doesn't exist, then we want to return an empty optional. Okay, so what does that give us? Good. And we're going to provide a SQL query, a row mapper, and then the parameter. The parameter is the ID. We're going to say reservation where ID equals question mark. Okay, let's say reservations. We say if reservations.size greater than 0, then we can return optional dot of nullable reservations dot iterator dot next, else just return optional empty. Okay, good. So that's the next one, and then finally we need to save data when asked to, and so this one's very straightforward, believe it or not. This one is a template. We're going to execute a query. We're going to say update, or yeah, we want to update. We want to have that. Okay, so update reservation, set name equals question mark, where ID equals question mark, and then we have here a prepared statement setter. So it's a new prepared statement callback for a reservation. Alrighty, and we're going to say prepared statement set int 1 equals to reservation.getName. Alright, sorry, set string, and then this will be the int to set int. Alright, and then finally just find the results. So find by ID reservation.getID.get, because we assume that by this point we have a valid record. Okay, so there's there's all of our code. We can return the result, of course. Drop that out. Good, so this is a repository. We don't really care about the repository so much. We just need that to be able to write the code that uses it. Okay, so collapse this, and now we can say, let's create a REST controller that allows us to demonstrate what happens here. So I suppose I should have brought in the web support for Spring Boot. Okay. Web REST controller class locked resource REST controller. Okay, and we're gonna have an endpoint here called update that takes the ID of the thing we want, the name we want to give it, and the time we want to wait afterwards. So reservation update path variable integer ID path variable string name path variable long time. All right, so there's our endpoint, and we're going to use, of course, our reservation repository. Good. And here we go. So here's what's going to happen. We want to be able to we want to be able to update the data, okay? So here's the business logic. The business logic is do the following, right? So we're going to say that we want to do, so void do update for integer ID, okay, string name, and here I'm going to say reservation. We're going to say find the repository, find the record by its ID. If the data is present, then we use the data to set the name to that, and then we save it. So we say reservation repository save or update R. Okay, and once that's done, we want to find the data. So find by ID again, ID dot get. All right. Now we've got the business logic. We've got the reservation result equals do update for ID with name. Now what do we want to do? We want to protect this code path, this one line. We want to protect it so that only one thing in the entire system can do that at a time for a particular user. In this case, the user will, we'll use the ID of the user as a key. So we don't mind if other people execute this method for other users, but if two nodes are executing the same code path for the same user, then we want to make it exclusive. Only one thing can update that user at a time. Okay, any one particular user. So here we can use the lock support. Okay, so we're going to say that we want to create a default lock repository. Okay. Return new default lock repository, passing in a data source. Alrighty, passing that in, and then return a JDBC lock registry. And the JDBC lock registry is the thing that you can, that's the thing that backs the data. It's the it's where we store the information about the lock, and it's why we can see the same state across multiple nodes, because we're talking to JDBC. There are, of course, other kinds of locks. So here's the core abstraction. And you can see there's a JDBC, there's a few others. There's actually a Redis-based one if you use Spring Integration Redis. So you've got options. It doesn't have to be JDBC. I just happen to like it. And we need the lock repository. That's this right here. Okay. Now we can use that here. Lock registry. And in the lock registry we say, okay, registry dot obtain, and we're going to use the key here. So string key equals integer to string ID. Okay. Good. Got the lock. And then we're going to try and obtain the lock or get a reference to it. So we'll say try lock. Better to specify a timeout. So I'm going to say I want to wait a second. I'm willing to wait 1 whole second for that result. Okay, now this could throw an exception, so I use sneaky throws to tell Lombok to swallow that potential exception. And I can say lock acquired? Question mark? Can I do question mark? Nope. And so we're going to say, okay, if lock acquired, then do that. Okay? And actually, I want to do this as well. I say try finally. So then it's lock, then unlock. Okay? Now, we've gotten the lock. We've done the business logic inside with the lock. And then we've scheduled that when the work is done, we unlock. Okay? And if we don't have the lock, then, you know, actually we can just do, we can actually clean this up a little bit. Let's make this void. Okay. There. So there's the business, there's the skeletal pattern, right? To be able to use this. So we're saying do the business logic, but only if you're inside the lock. And if you're in the lock, then make sure to unlock it when you finish up, okay? Good. Okay, let's try it out. So we're gonna run this 2 different times. In order to run it 2 different times, I need to get rid of this. Run the program. Hello? We need the ID and the name, don't we? So rs.getInt ID name. Good stuff. Of course, this could be a lambda. Okay. So now, localhost 8080 / 8080 / and then it's update, right? So we said update ID, and let's look at the ID that we have. pSQL. Okay. Let's update reservation. Set name equals Jane, where ID equals 1. So now we got Jane and John. Jane is number 1. Okay. So we're gonna go to the default port here. 512. Update 1 to winner. We're gonna sleep for 30 seconds. That's 30 seconds, basically. Okay. Over here, we're gonna sleep for 1 second, or 10 seconds even. Right? So let's try it out. Here's the 30 seconds, and so think about what's gonna happen. I'm gonna invoke the 30-second one. That'll basically keep the lock open for 30 seconds, and then very quickly, in less time than 30 seconds, I'm gonna go over there and start off the second tab, and that's gonna complete well before the first one finishes. Because they're in a lock, the second one should never get a chance to update the state of the record in the database to match the name that we're giving it, so it'll never show up as loser. And keep in mind, we've got the update here. Oh, we have to do thread sleep time. Okay, and I need to launch it twice. Okay, so the first node is running on this port. Okay, and the second node, the one that'll only take 10 seconds, is loaded on this node port. Okay, so here we go. 30 seconds, 10 seconds. So the first one's already returned. You can see that. It doesn't say Jane, or it doesn't say winner, loser. It says Jane or John. You can see in the background there, the first one is still spinning. It's waiting 30 seconds. Oh. What did I do wrong? Oh. I always do that wrong. Prepared statement. Dot. Execute. Okay, take two. Alright, so now this is the first node. It's on port 51393. And then this one is the second node on port 51408. So the second one says loser. Why did we... Okay, let's try this again. We've got two. Here's the first one. 30 seconds. Here's the second one. This is the first port. Is over here on the winner side. And then over here on the loser side, there's over here. Okay, ready? There you go. So you can see loser never, this is the old value, remember, it's still the old value. So let it finish, but it's already updated the state. You can see that because it returned when I did a query and I asked for the current state. I got winner over here on the loser side. It didn't update itself already. So remember, the thing runs, it writes the state to the database, and then it sleeps. So the value here is winner, the value over here is winner, which means that it never, it never got to it never let loser enter or execute. Okay. So there you go. there's a very simple distributed locks algorithm kind of situation or example. Kind of cool. I haven't had a chance to really play with this stuff before, but I can see a lot of different use cases. Obviously, this is really great if you have like message resequencing or that kind of stuff. If you want to make sure that you have only one person updating a particular record at a time, if you have some sort of stateful thing like a file in a file system, or some sort of session that you want to control, whatever, right? You can actually do some very interesting things here with these distributed locks. I'm using the JDBC based one because I suspect that a lot of people have that infrastructure available on their machines or in their services, but you could use other things. There's a Redis based one, and I think the Redis one is probably going to be faster. I don't know, but I expect that, given what we know about Redis and how fast it is and how tuned it is for this particular use case, I'll bet it's probably very fast if you're willing to give that a shot. So, my friends, I hope you enjoyed this, as always, and we'll see you next time.